Hi everyone, welcome back to the channel. Just quickly let me know if I am audible to everyone. Uh, Today is the fifth session for problem solving of game theory, mastering game theory series. So just quickly comment down below in the chat if I am audible to everyone, and then we'll start with the session today. Hi Divakar. Uh, I'll just wait for some time for other people to join in, and then we'll begin ahead with the session. So today is the fifth session for mastering game theory series, and as you know that we have done previous sessions. Yesterday I couldn't take up a session, so today we'll be taking this session, and in this session we'll be solving two problems. The first problem is ping pong, and the second problem will be GodSend, as we had discussed earlier. If we have time, then definitely we'll discuss one more problem, but usually we take some time. So I can see a lot of people have joined, so please like the video if you haven't already, and just tell me in the comments how many questions were you able to solve. Okay, how many questions did you solve in yesterday's educational round? Just quickly comment down below. Can you come with a series like this for DP? Yes, sure, we will come with a series for DP as well in future. Maybe after 1 or 2 months we'll come up with DP as well. Okay, you were able to solve the first three problems, so that is great. That is great. What about others? Just quickly tell me in the chat. So Nikhil is saying 3. That is also great. A lot of problems. Okay. I'll just wait for some time for others to join. Just 3 questions in 1 hour. Fourth was a nightmare. 3 questions in 1 hour. That is good. Okay, so shall we begin ahead with the session today? Shall we? Code chef. Okay. Okay, no problem. So shall we begin ahead with this problem? Okay, so let us move on with this problem. So the problem name is ping pong, and it was asked in CodeForces educational round 99, which was rated for division 2. Okay, okay, that is great. Right, so the problem name, as you know, is ping pong, and it is a game theory problem. So let us begin ahead with the problem statement. The problem is pretty simple to understand, but let's read the problem statement. This is the problem ping pong. Okay, so the problem says that Alice and Bob are playing ping pong with simple rules. During the game, the player serving the ball commences a play. So Alice and Bob are playing ping pong with the simplified rules, and basically during the game, the player serves the ball, commences a play. Okay, so when the player serves the ball, the play begins, and the server strikes the ball. When then the receiver makes a return by hitting back. So basically you can assume it to be something like a tennis game or a badminton game. Then thereafter the server and the receiver must alternatively return until one of them does not make a return, right? सर वो पहला वाला क्वेश्चन अच्छे से आ गया सीक्वेंशियल नेम ड्राई रन के बाद पिच पहले वाला अच्छा that is great. Basically that is why I'm taking these questions, like these questions, like this question also, this ping pong question, this is also a good question. And sequential name, you have known that, so that is also great. You should practice more. You can go to the tags and you can practice more, because there is only a limited number of questions, maybe only maximum 3 questions that we can take in a session, but you can solve maybe 5 or 6 questions in a day. So that is why you should practice more. Okay, right, let us move ahead with this problem. So the problem says that the one who doesn't make a move will lose. Okay, so let's suppose that this is a tennis game, and the first player who will not be able to make a move, he loses, and the winner of the play commences the play. Alice starts the game. So Alice is starting the game as always. Alice has X stamina and Bob has Y stamina. Okay, so there is something that has been given to us related to stamina. So let us see how we can use it. Okay, we have been given something that is related to staminas. So let us quickly see. So the problem says that they are having staminas, and Alice is having a stamina of X and Bob is having a stamina of Y. Okay, this is the stamina that both of them are having. Now the thing is that to hit the ball, each player spends one stamina, right? To hit the ball, you spend one stamina. So they don't have any stamina, right? If they don't have any stamina, so they cannot return it. Just let me know if everything is fine. Like, is there any lag in the video or anything like that? Just quickly let me know in the chat. Is everything working fine in the video? Just let me know quickly. Okay. So to hit the ball, the player has to give one stamina. He has to spend one stamina, or he cannot serve the ball. Okay. If both players run out of stamina, the game will be over. And sometimes it is strategically optimal not to return the ball. No sir, no lag. Okay, great. Okay, so sometimes it's strategically optimal to not return the ball, lose the current play, but save the stamina for the future. Okay. On the contrary, when the server commences a play, they have to hit the ball. Okay, so when you start the game, you have to hit the ball, right? So for that you need stamina. If you have stamina left, so you're using that. So both of them are playing optimally, and Alice is starting first. So you want to maximize the number of wins. Firstly, maximize the number of wins, and secondly, minimize the number of loses. So what you have to do is you have to try for both the players. You have to try to maximize their wins, and you have to try to minimize their losses, right? From the opponent player. So you have to tell. In the end, you have to calculate the resulting number of wins for Alice and Bob's both. Okay, that is what you have to do in this question in the end, right? So let's quickly see some of the test cases for this problem, and then we can think about it further. Okay, so let's make some space for us. Okay, let me copy the test cases. For this case, let's say if X is equal to 1, that is Alice is 1 and Bob is also equal to 1, then in that case, what should I do? Alice is 1, Bob is also 1, right? This is Alice, this is Bob. What can we do? Alice will start the game. So Alice will send the ball towards Bob, right? Alice sends it towards Bob. So if supposingly that Alice has spent one stamina, so now she is left with 0. Bob has one stamina, so he can return the ball. So he'll return the ball, and now Bob is also left with 0 stamina. And now Alice is, since she is not having any stamina, so Alice will lose. That means that Alice is having 0 and Bob is having 1. Alice is having 0 wins and Bob is having 1 win. Right? Is this clear to everyone? Is this first test case clear to everyone? Just quickly tell me in the chat. Okay. Moving on. Let's say if Alice has a stamina of 2 and Bob has a stamina 1, then in this case what can happen? You will say that Alice sends the ball towards the Bob. Then you will say that Bob will send the ball towards Alice. Then what will happen? This Alice is having only 1, Bob has 0. So you will say that Alice will, yeah, right, Alice will send, you will say that Alice will send again. So that means that Bob does not have any chance, so he loses, right? And the game ends because both of them will be having 0. So you will say that Alice will win 1 game and Bob will win 0 games, right? This will be your answer for this particular test case, right? Is this your answer for this test case according to the way you were trying to do it? Do you agree on this, that this was your way for doing this question, right? Can we do it in a much optimal manner? Is this the final answer that we can have, or can we do something better? You have to maximize the wins for both. You have to maximize the wins for both, right? And you have to minimize the losses for loss for both, right? You have to try to make the wins maximum for both of them. This will not be the case. This will not be the case. You are saying that the answer will be 1-0, right? This is not the case. This will not be the answer for this test case. Why? Let's now say that this was the previous calculation and it was 1,0. Now let us do it again. Let's do it again. Let's do the calculations again. Let's play the game again with one of the ways. Both play optimally. He didn't return, then lose, then Alice again send it. Alice start and Bob play optimally. He didn't send return and then lose, Alice again. Okay, right. So what we can do is Alice is 2, Bob is 1. Alice sends it, right? What was happening earlier was that if you played it one by one, then Alice will win 1, Bob wins 0. So Bob will say that why should I lose, right? Why should I lose? So he will say that let Alice play. Alice plays. Alice gives one shot, right? Alice gives one shot. So what will happen? Bob will not play. Bob will not play that shot, and Bob will lose. So Alice wins 1, and Bob has 0 wins now. So Alice has 1 stamina gone. Now the player who wins will be starting the game again. The player who will win, he or she will start the game again. So now after that, Alice will start. Now Alice will start. What will happen in this case? Alice starts. Alice sends the ball towards Bob. So now Alice is left with 0. Now Bob has 1 chance. So Bob will be playing this chance. So now his chances are 0. And he sends back the ball. Since Alice is having 0, so that is why she cannot return the ball. That means she also loses, right? For this case. So now number of wins for Bob will increase. So from 0 he will be having 1 wins. Earlier if you tried to do it without an optimal manner, so this was 1 and this was 0, right? Bob wasn't winning a match. But we can see that if we try to be a little bit optimal, then Bob also won a match. Bob also won a match. Is this clear to everyone? Is this much part clear to everyone? If this much part is clear, please like the video if you haven't, and please comment down clear. Is this much part clear to everyone? Just quickly tell me in the chat. Is this much part clear to everyone? Clear. Okay, great. Right. But let's take another case. Let's take another case. Let's say instead of 1-1, I had. Okay. Now this question is pretty interesting because this was a question number 3, right? So that is why this is a little bit tricky question, I would say. And since this is a game theory question, so you always know that game theory questions are always in those questions you have to play optimally, right? So let's do one more case. Let's say Alice and this is Bob. Let's say Alice has 2, Bob also has 2. What will you do in this case? What will you do in this case? What will be the answer? Can someone tell me? If Alice has 2, Bob also has 2. What will you do in this case? If Alice has 2, Bob also has 2. In this case, what can we do? What can we do for this case? Can someone suggest what we should do in this case? Anyone? What will be the answer in this case? And how? What will be the answer in this case and how? Just quickly tell me in the chat. What will be the answer for this case? What will be the answer? Can someone quickly tell me? Anyone would like to tell? What can be the answer? What can be the possible answer for this test case? I just want to know the answer from all of you. Chirag, Riya and others like Devankar, can anyone answer this? What will be the answer for this case? Anyone can tell me? 1, 2. Why? 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 You will say that Alice will start. Alice throws the ball, right? Now, should Bob spend his energy because he knows that Alice still has left, right? Bob knows that for this ball, the ball which has come, Alice hit Bob hit again. So you are saying Alice hit, Bob hit again, and then Alice left. You are saying that Alice goes to 1, then Bob goes to 1 after he hits, then Alice goes to 0 and she hits, then Bob has 1, he hits, and this is the case, right? Are you suggesting this case, that 0 comma 1? Are you suggesting this, Chirag? Are you suggesting this answer? This is answer from Chirag. Are you suggesting this answer, Chirag? Just quickly tell me in the chat. Is this the answer that you are suggesting? But can we do more optimal than this? Can we do something more optimal than this? Is this the answer that you are suggesting, Chirag? Just quickly tell me in the chat. Okay, so which answer are you suggesting? So what should we do? Just quickly tell me in the chat. Right, this is 2-2. What you will do? Bob knows, Alice knows how to win. Alice can win. Alice basically starts the game, so she has to keep on playing. If she doesn't keep on playing, she will lose, right? If a ball comes from Bob's side and Alice doesn't play that back, so Alice will lose. So Alice doesn't want to do that, but Bob can do that. Why? Let's try and see. Let's say that Alice starts, Bob misses this one. Okay, let's say Bob misses this one. Now what will happen? Alice is 1, right? Since 0 comma 1, no, 0 comma 1, let's see this. Okay, so Ria is saying 0 comma 1 will be the answer, but let's see, right? Now what can happen? Let's say since Alice has won, so Alice will start again. So Alice starts the game. Then what does Bob do? Alice starts the game and now she is 0. Bob will also play, so Bob will now become 1 and he will return the ball. So now Alice will lose because Alice can't make a move, right? Alice cannot return the ball, so she loses, right? Now again Bob has 1 point and the winner will start. The winner will start the new game. So that means now Bob starts. Bob throws the ball towards Alice, and since Alice move is 0, so she cannot make a move. So that is why what will happen? What will happen? Bob wins. Bob wins. So that is why Alice only won 1 game and Bob won 2. Is this much part clear to everyone? How Bob won 2 and Alice just won 1. And this is the maximum that we can have. Is this much part clear to everyone? You can, if you tried to be normal, then this would have been the case 0 comma 1. But if we try to be a little bit optimal, if both of the players are playing optimally, such that both of them are trying to maximize their scores, then in that case this will be the situation, right? Everyone agrees on this. Does everyone agree on this? Right. So this is the test case. Now let us have a look at some of other test cases. Clear? Okay. What about others? Let's say if I have been given 1 comma 7, then in that case let us check this test case out as well that has been given to us. Let's say if I was given 1 comma 7, right? So let me draw it. So if Alice has 1 and Bob has 7, so what will Bob do? Bob has got 7. What should Bob do in this case? You will say that Alice starts, then Bob can reply. So Bob wins, right? You will say this, right? So you are saying this. Is this the proper way that it should be? How many games will Alice win in this case? You are saying, let's say that Alice starts, and then what will happen? Alice is left with 0 moves. So now Bob starts and Bob hits. So now he's left with 6 moves and he wins. So you will say that Alice can win 0 and Bob can win how many games? 7 games. You will say that, right? But can we do something better than this? Is this the answer, or can we do something better than this? Is this the final answer? Bob always wins. So is this the final answer that you can have? Or all of them can have some, all of them can have something, right? Alice won, Bob always win. Bob always win, right? Can Alice have more wins? Can Alice also have wins? At the same time, Bob is also having wins. Can we have such a scenario? This is a special case. Let's for this, if we try to do this in this way, Alice is having 0 wins and Bob is having 7 wins. Can we increase the wins of Alice and at the same time keep the Bob wins same? Can we do this? I think that we can. How? Let us see. Let us see for this case. So for this case, what we can do is we can simply say that since Alice is having 1 move and Bob is having 7 move, previous answer was 0, 7. But can we do something better than that? Can we maximize the wins for Alice? I'm saying Alice starts, Alice will throw the ball, and I'm saying that Bob does not play that ball. I'm saying Bob doesn't play that ball. So in that case, Alice will win. Alice wins, right? Alice wins if Bob leaves the ball. After that, I'm saying that now Alice is left with 0 and Bob is left with 7. So now he will 7 times he will throw the ball towards Alice, and for all the 7 times Alice won't be able to make a move. Alice won't be able to make a move. So that she will lose and Bob wins. Bob continuously keeps on winning. So 1, 7. That means 1 win for Alice and 7 wins for Bob. While the previous answer was 0, 7, and this is much better and this is much optimal, right? Everyone agrees on this. Everyone will agree on this. So what can you draw some conclusion from this? Can we draw some conclusion from this? What is the conclusion that we can draw from this? Just quickly let me know in the chat. What is the conclusion that you can draw from this? Is there any conclusion that you can draw from this? Any conclusion or any pattern that you are able to trace after taking so many cases? Any pattern, any conclusion, anything? Just quickly let me know. What is the pattern that you can observe here? Like how to maximize the wins for both. Now the question is, how will you maximize the wins for both of them? I am asking, how will you maximize wins for both of them? Just let me know that. How to maximize wins for both? How will you do this? That is what I am asking. Can someone in the chat tell me? Just quickly let me know. Let us look at some of the test cases. If you had 2 moves, let me remove this part as well. If Alice had 2 moves and Bob had 2 moves, then we concluded that Alice will be able to win 1 game, right? Wins. This is moves and that is wins. So if Alice had 2 moves, then Alice will be able to win 1 game because she is starting the serving. That is the disadvantage that she is having. Since Alice is starting, so that is why. Since Alice is starting, so that is one of the disadvantages that she is having. 1 move of hers, she cannot win all the games that she cannot win all the x. She can only win x minus 1. Why? Because she is starting. So that is why, since she is serving, and then if in that case Bob will, for the last chance, like what will happen for the first chance, she will play and Bob will not play it, okay? But after that, what will happen? She will play, then Bob sends it back again and Bob wins, right? And after that, Bob will play and Bob wins, right? So for one of her chances, when she throws the ball at him, so Bob also throws the ball back. That is why one chance gets wasted. One move gets wasted, right? One move gets wasted. Are you able to clearly understand this? One move gets wasted. Are you able to get this? Why one move is getting wasted? For Alice, this one move get wasted where she's sending the ball towards Bob and Bob is hitting it back and winning. In that case, she is losing. Everyone agrees on this. That is why finally we can conclude that if there are x number of chances, then one of the chances of Alice will go as waste. That is why if x and y are given, so the number of wins for Alice will be x minus 1 and the number of wins for Bob will be y. Everyone agrees on this. Does everyone agree on this? Everyone is clear with this? Everyone is clear with this answer? Why this is the case? This is the number of moves that you can do, and this is the number of final wins. Everyone is clear with this case? Just quickly let me know. Everyone is clear with this? If everyone is clear with this, please give a +1 in the chat. Yeah, if Bob will hit back, so then her move will go waste. That is why she is only winning x minus 1 number of games, while Bob will win all y games, because since Bob is hitting back, he will win that game also, and he will win all the other games where she is not left with anything, right? Everyone is clear with that? Okay, let's quick. Shall I code for this? Shall we code? Shall we start coding? Okay, let's start coding for this problem. What you'll be given is, you will be given x and y only. Okay, so let's take the input c in x and y. First of all, let me declare them. So let's say long x comma y. In this case, you just simply have to take this and you have to print x minus 1, and with a space you have to print y. Okay, so let me copy the case. Okay, let's try and see what happens for this. Okay, so I'm going to submit the problem. You can see that it got accepted, right? This was very simple. This was a simple implementation, was simple, but the logic part was a little bit tricky. You had to run some circumstances, usually for such, as I told you in the previous sessions as well, the previous 4 sessions that we have had, that when you get such circumstances, then you should be running the algorithm and you should be trying to see what is the optimal situation, and in this way you can find the final answer. Is this part clear to everyone? Just quickly let me know. Is this, if this much part is clear and you haven't liked the video, please like the video. Is this much part clear to everyone? Shall we move to the next problem? Shall we move to the next problem if this problem is clear to everyone? Shall we? Okay, so let us move to the next problem for today, and that problem is GodSend. Okay, Ria is giving a +1. Okay, perfect. The next problem for us is GodSend. Let us quickly have a look at this problem as well. Let's make some space. Okay, let's see what the problem has to say. So the second problem goes by, it was asked, it is GodSend, and it was asked in round 7 429, dated for division 2. Okay, so it says that Leha somehow found an array which consists of n integers. So there is an array that she has found, and the array consists of n integers, and looking at it, he came up with a task. So this guy came up with a task by looking at it. Two players play the game on the array. So you are playing the game on the array, and players may move one by one. Players are moving one by one. Players are making a move one by one. The first player can choose for his move a subsegment of non-zero length. He can choose a subsegment of the array with an odd sum of numbers and remove it from the array, right? So the first player can choose an odd segment of the array and he can remove that part. After that, the remaining parts get together and become one array, and the game will continue. The second player will choose another subsegment such that it is at least of length 1 or greater, and that guy, the second player, will choose even. The second player will choose the subsegment such that it is even and remove it. So the first player who is not able to make a move, he will lose. The first player who is not able to make a move, he will lose, right? This is what has been given in the question. So for this, you will not require any test case for this problem because there is no test case given. You'll just be given one test case. So what you have to do is, let's say you have been given this test case 4. Is this part clear to everyone? The first player will remove the even elements, and the second player will first player will remove the the segment will odd sum, and the second player will remove the segment with even sum. Is this much part clear to everyone? Just quickly let me know. Is this much part clear to everyone? The value of n is 4. In this case, what can we do? What can we do for this case? The player will try to win. What should he do? What should he do? Just quickly let me know. Quickly let me know in the chat. What will be the outcome for this array? If this is the array, the first player, what is the sum of all the array? The sum of all the array is 4, 5, 6, 7, 8, 9. So the total sum is 9. So since the total sum is 9, so that is why in this case what will happen? Since the total sum is 9, so that is why when he picks this much, what will happen in this case? He will pick all and first player wins, right? First player wins. Is this much part clear to everyone? Just quickly let me know. Just quickly let me know. Just quickly let me know. Right, this is clear to everyone. Okay, perfect. Perfect. What is the other thing that we can do? What is the other thing that we can do? Just quickly let me know. Is there anything else that we can do? Let's suppose that the array was of size 2 and it had 2 elements. If this was the case, if the array was looking like this, if n value was 2 and the array looked like this, so in that case, can first win or the second will win? What will happen? What will happen in this case? First loses, right? First loses because he cannot pick any even segment. So second one will win, right? Everyone agrees to this. Everyone agrees to this. I think everyone will agree to this, right? So what are the conclusions that you can draw? Can you find any pattern in this? Can we find any pattern? Any sort of pattern in this? Yeah. Right. Sethi, you are right. Any specific pattern for this problem? Can we find any specific pattern for this problem? Can we? Any specific pattern for this problem? Like how do you determine the winner? That is what I am asking. How to determine the winner? That is what I am asking you. How will you determine the winner? That is what I am asking. Let's say you have been given an array. Let's say you can be given anything. Let's say 1, 2 and 3. In this case, what will happen? Just let me know. If the array is 1, 2 and 3, then what will happen? If the array is 1, 2 and 3, who will win? The first or the second one? Odd plus odd, even, odd plus even, odd. This is perfect, but how can we use this? Like, what do you think? First of all, tell me the answer for this case. So for this case, what will happen? The first will win pick this element up. He will pick this segment that is odd. After that, the even person can pick this 2 up. That is the second player can this pick up. Then the third player will pick this up, and when the fourth one comes, so second loses and the first one wins, right? First wins because now nothing will be left. Everyone agrees to this. how do you determine a pattern, right? For this problem, can you determine any pattern, any sort of pattern, any sort of pattern that you think that we can find? Any sort of pattern, any sort of pattern that we can find for this question? Anything that you think that we can do? Like, we can keep on taking, you can keep on taking test cases, but how will you determine who is going to win? How will you determine that which player is going to win? He pick 1 and 2 because all sum is okay. So how do you determine that which player is going to win? Let's say I can give you a lot of test cases, right? Let's say you have 2, then you have 3, 4, 5, 6, 7, you have these type of cases. Or let's take more generalized cases. Let's say this is 6, let's say this is also 6. In this case, what will happen? Let me do it like this. Let's say this is 3, this is 3. Then in that case, this case, what will happen? Which player will win? Number of odds and even. Okay, so one guy is suggesting number of odds and even. For this case, first of all, tell me the winner for this case that I have picked up. Just let me know quickly. What do you think will be the answer for this case? Anyone would like to tell? You are saying that number of odd and even. Like, when will the first player win? Just tell me, when will the first player win? Is there any situation when the first player wins or the second wins? Is there any particular situation for that? For it, is there any particular situation? Any particular situation for that? First will win. You are saying for this case, the first wins. How? You are saying that first can pick this 3 up. Then I'm saying that, let's say he picks this 3 up. So what will happen next? 2 can pick all this up. 2 can pick all this up because all this is even. So I am saying that second wins. But how can you say that? I am saying that second wins. But how are you saying that first wins? Just let me know quickly. I am saying that second will win. But how do you see that first wins? Because you will pick this whole up, right? You will pick this up, right? You will pick this up. You are saying that you will pick this up. Then I am saying that second one will pick this up. Then even after that, second one will win. So how do you determine that who is going to be the winner? Who will be the winner? I want to know from all of you. For this case, who will be the winner? Situation for second when sum is even, when sum is even, odd. Okay, right. That is what I wanted you to realize. This is 18, then this is 22. So this much is 22. Then you add this up with this number, right? So that means that simply means now you have come to the conclusion part, right? Right. If there is at least one odd number, at least one odd number, right? Then what will happen? Then first wins. Is this case clear to everyone? Just quickly tell me. Is this case clear to everyone? If there is at least one number, one odd number, then you will win. Why? Let's say there is this element. Let's say there is an odd element, okay? I'm denoting the odd as O. So there is an odd element. Let's say other elements are even. Let's say the whole sum is even. Okay, the rest of the sum is even. You are saying that rest of the sum is even and this element is odd. So I am saying that the first player will pick this whole up because this whole will be odd. So first wins, right? Everyone will agree to this. Everyone agrees to this, right? Now what I am saying is, yeah, if there are two odd numbers and there is one even number, right? If this is the case, so in this case the first player will pick this up, then the second player will pick this up, and the first player will pick this odd number up, and again first wins, right? And there can be one situation, you will say that if what if there are three zeros and there is this even, then you will say that if the first one picks this up, then this whole will be even and the second player will pick this one up. But I am saying, what I am saying is this complete will be odd because there are odd numbers, right? This complete will be odd and again first one will pick all up, so first wins. Are these test cases clear to everyone? Are these test cases clear to everyone? Just quickly let me know in the chat. Is this part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Is everyone clear with this much part? Is everyone clear with this much part? Everyone is clear with this much part? Clear. So what will be the situation in this case? What will you do in this case? Basically, if there is at least one odd number, then the first player wins, otherwise he loses, right? That is the scenario for this problem. So let's quickly implement this problem as well. Okay. This will be long, let's say n, and I say I, and I'll initially mark my flag as 0, indicating that there is no odd number, or let's say I can have a count for the odd numbers only, so I'll mark it as 0. Then what I'll do is I'll take the value of n as an input, then I'll declare the long array a of n, right? After this I'll simply take the array elements as an input, that is this, and once I take them as an input, that is C in ARR of I, after that if ARR I and 1, do you know this, that ARR I and 1 is odd, that if ARR I and 1 is there and if this comes out to be true, then it is odd, right? Just let me know if you know about this as well, the bits, using this using bits instead of using the modulo operator. So if the count of odd numbers is greater than 0, so in that case what you will do, you will say that first one wins, right? What does it say? You will write first, otherwise you will write second. Okay, so you will say that first and you will change your line, else you will say that second. Great. These are some of the techniques, like this works faster than the modulo part. Okay, this was a good problem, right? You did not have to consider any even, but how do you think about such cases? You have to take some random cases, right? For such problems you have to think about some random test cases and then you are able to come up with some solution. Okay, so let's see if it is giving, it is giving some compilation error. Let's see where it is giving a compilation ARR. Okay, I'm using ARR. Instead of doing that, I should be doing this. Let me now submit this problem up and see whether it works or not. Let's see whether it works now or not. So it is running on test case 30, 34, 38, 42. Now how much? 76, 88. It got accepted, right? You can see that this problem also got accepted and it was a good problem, I would say. Like, it was rated as 1100. You just take the input count. If the count of odd numbers is greater than 0, that means that the first player is always going to win, right? And that is the case. Okay, so is everyone clear with these problems? If you are clear with these problems, then please write clear in the chat. Please write clear in the chat quickly. So let me tell you the problem for tomorrow as well. Right. So for tomorrow, let's quickly open CodeForces. Let's go to this problem set. So let me go to this game part. Okay, so we have done these questions. These many questions have been done by us in game theory. So tomorrow we'll be doing this game, um that is Poland ball and game. Then we'll be doing this game that is known as Spider-Man. This game theory question, that is Spider-Man, and then we'll also be doing another question, that is even odd game. So we'll be discussing three problems. The first problem for tomorrow will be Poland ball game. The next problem for tomorrow that we'll be doing is Spider-Man, and the third problem that we'll be discussing tomorrow is even odd game. Okay, was today's session helpful to all of you? Just let me know. Just let me know if today's session was helpful to all of you, and quickly comment down below what are the topics on which you want the further sessions to be. What are the topics that you want? What are the topics that you want live problem solving on? Can you comment down below? What are the topics that you want me to take in live streams so that we can solve them together and improve our problem solving skills? What are the topics that you want me to take live? Just quickly let me know in the chat. Like, the problems were good, they both of them were 1100 rated. Now we have been doing this for some time. I think that this was the fifth session for game theory, and we have done 7 for greedy. Since we have done many, that is why both the problems were rated as 1100, right? What are the topics that you think that I should be taking up in future? Just quickly let me know in the chat. What are the topics that you want? GCD, DP, okay. Any other topic that you think that we should take? Okay, DP, and basically you are saying number theory. Number theory, problems based on number theory, or you can say primes, GCD, all these things, right? Okay, and strings, okay. Strings, right? This is one of the topics that we can do. Then you have DP, okay, matrix type of problems as well, right? Perfect. Okay, so moving on, like I'll be telling you, so we'll be doing I think that we'll be doing live streams today as well. Then we'll be doing Friday, Saturday and Sunday. We'll be doing we'll not be doing it on Sunday, I think. So we'll be doing 2 more live streams now for game theory. Is that fine? For game theory, 2 more live streams, one for Friday, that is tomorrow, and one for Saturday. And after that, from Monday we can start another topic. Is that fine? From Monday, new topic. Is that fine? Is that fine? Trees and binary search trees, the essay part. Is that fine? Will you like to have 2 pointers? Anyone would like to have 2 pointers for DSA? Do you want this? Do you want 2 pointers for DSA? Do you want this topic to be taken? So we'll have 2 more sessions for game theory, because after that I think we'll be covering 1300 to by doing that we'll be covering at least 1400 rated problems. So this is enough for becoming something like a specialist. String hashing, okay, string. So I think that then we should pick string from the next time. From Monday we can pick up strings as well. Strings कर सकते हैं, we can do strings. but strings will cover. Okay, so strings can be done, so I'll see whichever, like I'll do some research part and we'll see that what topic we can do. I'll update you about it on Saturday. I'll update you about it on Saturday. So we'll be having the session 6 on Friday, that is tomorrow, and we'll be having the session 7 for okay, that so right. Okay, so that is it for today, and we'll meet soon. Thanks a lot for joining in. And in case if anyone has doubt, I can see a lot of people are watching. So I just wanted to inform you that you can check out the playlist on this channel. We have had several playlists. That is Mastering Greedy. We have done Mastering Greedy game theory, Greedy series. Like let me show you the channel as well. Okay. So talking about this, so this is the channel. Let me show you quickly. So this is our channel, and here we have tried to provide a lot of things to all of you. Like if someone wants to check out, so we have Mastering Game Theory series. We bring editorials for almost all the contests that happen on CodeForces. Apart from this, we also have Google Kickstart. We have Lead Code Daily. We will be trying to be a bit more regular with them as well. So 2 pointers will be also be okay, sir. We will do it. Don't know how to use in CP. Okay, right. So this is you can check that we have a lot of playlist. So we are building upon that. We are trying to build a community to help people. So you can try to practice using this channel if you like, and you can recommend it to your friends as well. Thanks a lot for everyone for joining in, and let's meet tomorrow. Right.